hope you are totally pumped up, amped up. We got 2 more hours to blitz today, and we're gonna just totally destroy it. All right? Yeah. Yeah. All right. There we go. There's some energy. Here we go. All right. Thank you. Yeah. The more energy you give me, the easier it makes my job to give you energy. Right? Just like any theater performance. Right? Any thespians here? Yeah, we got some. Brutus, nice, love it. Okay, so what we're going to get a little intro of today is something that you're going to use a lot in JavaScript, and it is called class. Right? Because we all want to be classy, we all want to have some class, and so today we are going to learn about such things. Such fine things in life as class, yeah? So, class is a big part of the second paradigm of JavaScript, right? So there's 2 main pillars and paradigms of JavaScript. The first one is called functional programming, okay? That is mostly what we've been doing so far. That's how, if you added functions to your Hangman game, you have most likely were doing something called functional programming. That's functions that call other functions that just call other functions. Yes? Today we're going to start learning about object-oriented programming. So this is breaking down everything we see into an object. Right? Now we're already familiar with objects to some extent. So we're going to learn a new way to construct objects that's going to set them up into different classes. These are going to be called classes today. They're built off of the idea of constructor functions, which is an ES5 concept that we'll dive deeper into at a later point in time. But first we want to focus on classes because we're going to be dealing with classes the most. Okay, questions on that idea? Okay, so little small context, right? We've been making arrays where we've been saying let array equal, and we've been putting the data structure straight up as it is, yeah? Okay. Right, and there's nothing wrong with that. And if I wanted to initialize this with 1, 2, 3, I could do so as such. Hopefully nobody has any questions on that. So array is a type of class, you could think of it, in JavaScript. So what do I mean by that? Well, I could also initialize an array by saying let array equal new array. What? Console.log array. And we can see that this is giving us back an identical array as before when we were just creating an empty array. Okay? So this is another way to initialize an array. We know from previous experience, hopefully, that if we say, if I click into here and I say type of, and I run this, we see that array is a type of object, right? That is because array is a class, and classes create objects. Right? They might not look just like curly brackets, because we see an array really doesn't look like that, but it is an object under the hood, and that might not make perfect sense to you now, but hopefully it will in a little bit. Okay, well, it'll make some more sense to you in a little bit. Perfect, we'll see. So the syntax to this, to creating a new instance of a class, is to say this keyword new, and then the name of the class. Notice that it's capitalized, and then you invoke it like any other function. With array, I can also pass in arguments, such as 1, 2, and 3. And this will give us a regular array of 1, 2, and 3. This is just a different way of initializing an array. Do I recommend now initializing all your arrays like this? No. I would continue to keep it as just the square brackets. That is the standard. That is more normal. That's less writing. That being said, this is a possibility. This is something that exists because array is just a class like many other classes. So let's see what it might be like to build our own class. Yeah.
When I do that, and I'll put in only one value,
Mm-hmm.
or like two.
You're doing this?
Yeah.
I don't know. That's a peculiar behavior, right? That's totally unexpected. I'll have to look into that more. Celine, John, you guys happen to know that one? No. That's a really weird point. I would like to pretend that we just ignore that for now, as we most likely really won't be creating arrays like this. But oh, you know what it is? I know what it is. I'm sorry.
Is that because like an array has to have more than one like property?
No, I know what it is. So I don't know why I've spaced it out. So if you pass in multiple things into an array when you start, it will take all those arguments and put them into the array. If you pass in just one thing, you predictate the length of the array. So this is really helpful for other languages. So JavaScript has something called dynamic arrays, which means we don't have to say how big that array is going to be, and we can keep adding to it, and it will keep working. Other programming languages have static arrays. A static array is we say, okay, we're going to create an array, and it's going to be the size of 4. And once we've put 4, that array is full. So you can't just keep pushing. You have to create something so that it builds a new, bigger array that you can push it into. So that's what's going on. This predictates the length of the array. But since JavaScript is still dynamic, we can still keep pushing, and it won't care. Don't get too caught up on that though right now. But that's a good catch. So let's see what it might look like to create our own class. So today we dealt with a lot of people objects. Yes? In an array. Specifically, we had something like name, we'll say Corey, and then we had, I'm just going to remake it a little bit. Name, we'll have Rick. I should be adding age in here. I want to prove a point in a minute. Age, Rick is, how old is Rick? Do we know? Oh, Corey, that's me. 100. Rick's probably 72, right? 72. And then we'll also have Morty. We'll just have the trio. I'm trying to get in an episode, so. Alright, and. What?
Morty's like 12, right?
Yeah, Morty I think is around.
No, Morty's like, no, yeah, 14.
Okay, 14. Alright, it doesn't really matter. So let's say I have this array of people. Okay? And just for fun, I'm going to iterate through this. So we will see how to make our own, but I just want to make a couple points first, yeah? So we're going to iterate through this. So I'm just going to say people dot for each person, and I'm going to console.log person.name. Okay? This should be like nothing too weird here, right? Okay, but what if I had accidentally misspelled Rick's name and made it Nam? What do we expect to see here?
Just 40 and
Well, we're going to see still everything, but there is no key at name for the Rick object. So we just get back undefined, right? So this is not good, because we were expecting uniform data, yes? We shouldn't have to deal with misspellings. This is one of the many benefits to creating a class that's going to build an object for us. Because we'll be able to reuse this code for every object so that they will all be uniform. And if you don't know what I mean yet, you will soon. Okay. So I'm going to comment this out for now. So let's create a person class. So you start with the word class, lowercase. You then name the class, capital. Well, it's actually called proud camel case because it starts with a capital and then we'll continue with camel casing if you have multiple words. So we'll say person. Then we'll give it some curly brackets. And we have our person. Okay? Now, inside of person, we have the constructor, which is the key word, constructor. Parentheses, curly braces. Okay? It's a weird syntax, I know, to start, but it's not too bad, don't worry. So the constructor gets run every time you initialize a new instance of the class. So every time we call new person or something, this constructor function will run automatically. Every time. So we want our person to have a name, so and an age, right? And so every person should have a name and age. So we're going to go ahead and pass these into the constructor. So I'm going to say name, age, and then in here I'm assigning this dot name equal to our name, and this dot age equal to our age. What do we think? How do we feel about this? Yeah, Henry?
So, just so I could understand, this is going to fix whatever objects are in the cell?
Yeah, we're going to see how that helps. Yeah, don't worry. We'll get back to that for sure.
So this creates an object called person.
Yeah. Okay, so let's see it, right? Let's experiment. First things we should know, again, so we have the keyword class, we have the name of the class, in proud camel case, we have curly braces, and inside you have a constructor function. You will always want a constructor function until unit 4, when we're dealing with React, you might not always. But for now, always, okay? You're always going to want this constructor function. Every time we create a new instance of the class, the constructor function will run. So let me show you what I mean. And the this inside is referring to this as in the object. If you remember from the other day, we did this and we called the function style, which is regular parentheses, and we saw that this was the window. Remember that? That big stuff with all that crap in there? Set interval, set timeout. Do we remember that? And then when we were doing that like array.prototype thing, we saw that this was whatever the method was being called on. Now our this is referring to the object, specifically the instance of that object as a whole. I know, that's a lot to take in. So we're going to go over this again too. So we'll say let Corey, and I'm going to create a new person, so I'm going to write new, my person class. I'm going to invoke it, and here I'm going to pass in the arguments that my constructor is expecting. So I'm going to say Corey, and I'm going to put in 100 for my age. Okay, so now, I know it's funny because there's no returns or anything, but this is just how it's set up. So now if I console.log, my Corey, Corey is an instance. That's really important to remember, the word instance. So every time you create one, it's an instance of that class. Instance of the person class. Okay. So if we console log, let me clear. We'll see that person, or that Corey object, is this instance of the person class, and that is an object with the keys name and age pointing to their respective values. So, what does that mean? Well, if I wanted to get my name out of here, I could say Corey dot name, just like any object, right? I could run that, I get my Corey back. If I wanted to get age, I could also do it, right? Bracket style, say age, run that, I'll get 100. So it's just an object, but we've created this via a class. So now everything will be spelled correctly if I create 3 instances of these, because it's already set that they'll all have this name pointing to name, age pointing to age, right? I only had to write that assignment one time. Yeah, Doug.
Should you write that and then whatever it is, should that always be unique?
This one?
Yeah. Let's say like
Well,
multiple cores.
You wouldn't. Yeah. So then you wouldn't have multiple because if you're creating a variable, you can only declare the variable one time if it's within the same scope. So it will throw an error if you try to do it again. So you wouldn't really have multiple queries, probably. Not at this point, at least. That's a good question, though. Yeah, Sam.
If you have an object already with instances already, how can you like look at all of them? Is it possible to look at all 3 instances? Like what if I forgot that that's what that was called? Is there a way or no?
So you.
Like the instances don't
So
pop up.
the query is the instance.
Right. The query is not in the object.
Yeah, right. But this is just an instance that I created. So you like wouldn't forget because you specifically would have to create
So
it.
it's like intentional, like there aren't just instances in objects.
No, the instance is not. The instance is just
It's
its own object that we just created.
Okay, I understand. Okay.
So if I to go back to this example, I could instead of writing all this, we'll do it again. I'll just break this, and I could create Corey up there, right? Or I could say let people equal an array, and I could say Corey. That was the first one. So I could create 3 there, or I could just create them right here. I could say new person, pass in Rick, pass in, I think we said 72, and I could say new person, pass in Morty, and we said he was 14, right? And so now when I iterate through this, I can say people dot, oops, for each person console.log person.name, and when we run it, we get Corey, Rick, and Morty, and this time there's no accidental misspellings. So that's a big help, right? This gives us good data. This gives us clean, reusable data.
Question. This only happens when, like, in the object here that you create a new. Let's say you got name here, right? You got name, you got age. Can you create another group like this sex, for example?
Sex?
And then,
Sure. Like I could add it right here. This dot sex equals sex. I could just have this say like, I'll default this to yes, please. Right? So, still will work. If we go back to logging just the object, we'll just see that now it has another property. Right? But we could have changed it, right? If I wanted that, just say mail. So, no problem. You can add as many things as you want there. Good question. Any other questions on that? Okay. So, take the next 5 minutes and create your own for the class animal and give your animal a couple attributes, okay? We used it earlier. That was on purpose. Don't forget, I'll slack on all this code. So if you're not as quick as typing as me, I'd rather you work on trying to do an animal than recreate all the person to which you can copy and paste after pushing it. need more time, or are we pretty much there?
More time.
Okay. Couple more minutes. All right. You're talking. All right, clap your hands once if you can hear my voice. Awesome. How did this go? How did we do? Pretty good. Mostly all thumbs up there. So when does, who can tell me when the constructor class runs? When does the constructor function run? Marvin? Yep, so whenever substantiating a new instance of the class, or instantiating, whatever the word is, right? As soon as you've created a new instance of the class, the constructor function runs. Notice how in our person, right, we're just passing these in. These automatically get passed into our constructor, and this automatically sets all of those values into our class object, yeah? Okay. That's good to know. Let's go over the animal one. I can leave that for now. Okay. So what's the first thing I needed to do? Class, right? So I'm going to say class. I'm going to call this animal. What kind of case should this be in? Proud camel case, right? What's the difference between camel case and proud camel case? The first letter, proud camel case is capital. Regular camel case, the first letter is lowercase. So we'll say animal. What's the next thing I need in the syntax? Curly braces. Thank you. So I say curly braces. What's the next thing I need? Constructor, okay. And I can pass in a series of arguments. I guess we can have name, right? Animals have a name. And maybe a color. I don't know what else we really need. Okay, I will say leg count. Sure, I'm into that. That's it. I don't want to get too crazy. So we'll say, and then how do I actually assign these into the object itself for feed? This dot name equals name. This dot color is console log is color.
This
Equals leg count. All right. Okay. So let's test that this works. Let's say we do. Let's create a horse, and we can say new animal. We'll name this animal Orange Pop. And then, right, so the order that you pass the arguments in, right, just like any function, matter, right? So it has to be in the same order. Color, I guess a horse is brown. Do we want a brown horse? Custard? I kind of like custard. No, we don't. Okay. You want a white horse? What color was Custard's white horse? White, okay. Well, whatever. And then we'll say leg count. I don't know how many horses. Four. I don't have a lot of horse experience. All right. No, I'm just horsing around. I totally know. Okay. So we can just console.log, and we can look at our horse.
So you have to put the leg count in parentheses, even though it's a number?
No, I don't. That was a mistake. Good catch, Ashia, right? I wasn't looking, but I think that was your voice, right? Nice.
Question, does this have to be capitalized?
No, this should not be capitalized.
It should be lowercase.
100%, yeah. And we see we got this animal named Orange Pop. That is the color white and the leg count of 4 for now. Okay. So far, so good, right? So, this doesn't really seem like. Oh, yeah, Jay?
Does it log the animals because of the animal class?
Yep.
And it'll do that.
Yeah. You don't. It's just kind of telling you what this instance belongs to. That's just how it logs it. Sin? If you what?
If you create another animal, is it possible to log both by putting in like class animals, like console.log?
So okay, so let's walk through it because I'm not sure I understand the question. What animal do we want to make? A seahorse? That seems kind of fun. Let's name the seahorse Strawberry Cream.
Okay.
Strawberry Cream. I think a seahorse is blue. I don't know. White? Are they also white? Red? All right. I don't think they have any legs. Yeah. All right, we got like some sticklers for the legs. My seahorse has no legs. Okay, Sin, what do you want me to do?
Alright, so obviously if you console log seahorse, then seahorse will come up, right?
Yeah.
But how do you get both to come up? A horse and a seahorse.
Well, I could console log 2 things. Like that?
Without doing that. Is there a way without like console logging
Well, I could
each thing?
do it like this.
If I have 100 animals, I'll have to write out like the name of each of those 100 animals.
I would put them in an array and then iterate that. I 100% would not do that for 100 animals. But yeah, we could just do it like that. Good question, though. Okay, so right now the objects are kind of boring, right? Like we can't really do that much. We're just like seeing their properties. I guess we could reassign their properties. But they can't really interact. They can't do too much, right? So let's change that, right? So let's go back up to our person. And what's something a person says when they're hungry? I'm hungry. I like that. So we can write a question that says, so outside of our constructor function, if we want to, we can write functions or methods that will be called on the instance of the class. Let me show you what I mean. So we can have a function called is hungry. That's expecting a Boolean. I'll just say hungry. And this is a function that says we will return the string of I, and then we can access the properties of our object itself, or this. So if I can say, like, I want to say the name, so I, this dot name, am hungry. Okay, not too killer, yeah, not yet. So we have. So now we have our constructor function. This runs when? When does the constructor function run? Jay?
Whenever you're creating a new instance.
Right. Every time we create a new instance of the class, our constructor function runs. When does hungry run? So hungry is going to run when I call hungry. So let me show you how I call hungry. Down here, I'm now going to say console.log, and I'm going to say Corey.hungry, and I will invoke it, right? This is just like how we've been calling functions method style, right? Like for each, for map, array, filter, pop, push, right? These are all method style functions. So now when we run this, We get I, Corey, am hungry. Brandon.
Would you be able to do the same thing if the function was outside of the class?
No. Good question. So Brandon's question, to repeat that, he says, can we do this same thing if this function is outside of the class? And my answer was no, not in ES6. In ES5 we can do it, but we have to do that prototype thing that you may have saw in the bonus, which we'll go over some other time in the future. But for now, if you want it to run, it has to be inside of this class. Everything inside of this class is fair code. Okay? So I want you, so let's do one together. What else do humans like to do? Sleep. They love to sleep. Henry likes to use the restroom. That's great. Total respect. That is true, right? Okay, so let's do sleep. So we'll say sleep. And let's take in a energy status, let's pretend. Energy status. Right? We can still pass in arguments. That's the point I'm going to be making right now. And so we can say, in here we can do logic still. So I can say like, hey, if, we can write this just like any other function we've written. So if my energy status is greater than 50, so if it's like more than 50% my energy, I will return wide awake, no sleep for me. Else, return ready for sleep. Okay, I don't really know. It's not like a great function, right? But like it's just to demonstrate a point. So, if I would like Corey to sleep, how do I do that? How can I make that happen? So I got to do Corey.sleep. Does this take in an argument? Yeah. So if I want him to be ready for sleep, what do I need to put in? What? A number? What number? A number less than 50. So let's say Corey only got like 4.5, 5 hours of sleep last night. For sure. Corey.sleep, we throw in a 30. We're going to run it. Ready for sleep. It's like it knows me, right? Otherwise, I just had another cup of coffee, so I have more caffeine than usual. So right now I'm still ready for sleep. Yeah, there we go. I need one more sip. Now I'm wide awake, and I will never sleep again. Okay? Does this make sense, or are we totally lost? Okay. Okay. So I'll if you're totally lost, pull me. I'll come help you. Your next assignment then is I want you to create a couple functions for your animal that you created. Okay? I don't care what they are. Try to use in one of them. At least one of them, I want to take in an argument, and the other one, at least I want, and at least one of them, I want you to also use one of the things you passed in as its property. Yeah? So it should have a reference to this, and it should have a reference to, it should take in an argument. Add a couple functions to your animal class. Here, I'll write it specifically. Class. you go. All right. Okay, that's the best I can do right now.
Oh, yeah. Do the same thing.
It's like you realize it's something more things
All right. All right. Clap your hands once if you can hear my voice. Clap your hands twice if you can hear my voice. Clap your hands once if you can hear my voice. Okay. How did we do on this one? Okay, pretty good, mostly. Okay, so let's talk about it. We'll go down to our animal and start building out our animal. So an animal learns how to. Let's change our animal's leg count. Yeah. So let's write a function that says mutate legs. Mutate legs. And this will take in a number. And from here, we'll update the new leg count of the animal. So we'll just say this dot leg count plus equal num. And then we can either return our leg count, right? Or we could return anything. We could not return anything if we didn't want there to be a return value, like how for each has the return value of undefined. We could also return this. This would give us back the instance. So I'm going to do that for now, just so we can see what I mean. When I say return this. So what happens now? So if I take our horse, console.log, and I say our horse, and I say I want to mutate the legs, and I pass a -1, because I want to have a horse with 3 legs. What'd you say?
It's horse.
Okay. Well, this is a risky one. Okay, here we go. Horse, yeah? I want to take off a leg. I run this, and we see I got back the new horse instance. The instance of the horse, right? I have the leg count in here, but because I returned the keyword this, I got back the instance, the literal instance. What does that mean? What could I do if I actually returned the instance of something? What could be nice about that? Sure. As a human, but how could I use it? Yeah, Brandon? Okay, it's similar to what Kelvin said. Well, let's pretend I had another method, and maybe we'll come back to this question in a second. So, let's say I write a function that is makes noise, and I pass in a noise, and I will return this dot name plus makes a, and I'll put noise. Okay? Seems reasonable, yes? Okay. Questions on this function? Okay. So in here with my horse, let's go back to the horse. And I say console.log, and I go horse dot makes noise, and I say nay. Yeah? All opposed? Okay, great. And I run it, right? We get orange pop makes a nay, and then we also have, from our other one, the mutate legs, the returning of this. Okay. So here's something that's kind of interesting. Do we remember how map, what does map return when we're in an array? When we do array.map, what's it give us back?
A new array.
Gives us back a new array. That's all. Sorry, yeah. I don't mean to cut you off short. Jay says it, hey, it gives us back a new array. Do we agree?
Yeah.
Is that new array an instance of the array class? Yes, right? Every array is an instance of the array class. Okay, so because of that, can't I do dot map something and then dot filter something? Right, because I'm returning an instance. Right, so this is something that you could keep in mind, because if I didn't do make noise here, if mutate legs returns an instance of horse, which is like the very thing itself, this, I can also then say dot makes noise nay, right? I can chain my methods if I needed to. So then we say orange pop makes a noise. Oh, it makes a neigh, whatever, night. The horse has got a lisp. Okay? That's okay. Questions on the chaining? Yes, Sam.
When you say instance, what exactly are you referring to?
An instance is the object and its property. And I just want us to also note that when we print out the instances here, like this, we'll see that the instance has the keys of name, color, and leg count. But we don't see those functions. So the things that we see inside the object with our eyes are the things that we put into the constructor. Okay? If it's in the constructor, we'll see them as keys with our eyes here. If it's not in the constructor, but it's still in the class, it will still access them. But it does something which I don't really want to get into, but it's called going up the prototype chain. So that way not every instance has these specific qualities, but all instances can point to the same function. So what do I mean? Right now, each animal needs to have a different name, right? They all need to have a different name, because 2 animals have different names, 3 animals have different names. So they have to store that on the instance. Does that make sense? Hang on, before that, does that part make sense? Okay, so we have to store the things that are defining qualities on the instance. And that's how we see that. That comes through the constructor. Other functions like make noise, all animals make noise, yes? Every animal. And so I don't need that to be part of every instance. I just need that to be part of the class. If that doesn't make perfect sense to you right now, that's okay. Will.
So you ask if an instance is just a new version of the object.
It's, what do you mean by an inversion of the
A
object?
new version.
A new version.
Like a new object.
It is an object.
Yeah,
Yeah.
but modified. Like every instance is something that you modify.
Every instance is something we can modify. Yeah, we can modify an instance, for sure. Good question. Okay, so this is something that we could do. Let's see, what else should we cover? Okay. So, we've got this person. The person's got their name. The person's got their age, their sex, and then these are all going to be part of the instance, so we're going to see these keys. And then we have that the person also has these functions attached to it. We won't see these as keys, but we know that they will be available for every single person. Yes? Okay. So now we're going to learn a little bit about inheritance. Just a little bit. So your parents have some certain traits, yes? And then they made you, and you probably have some similar traits as your parents, yeah? Height, hair color, etc. Yeah, you probably like one of them at least, right? You have something in common with at least one of your parents. Please, I hope so. Your biological parents. If you have adopted, probably biological, right? But so we've inherited certain properties. We can do the same thing in programming. So let's take, for example, a zombie. So a zombie is a person, yes? And so a zombie has all of the same properties as a person, but they also have some differences. They have a few differences, like the soul that makes them you, right? You, what makes you you, the zombie has its own thing. Like humans don't really tend to eat brains. You know, cannibalism exists, but it's not like their soul, we only eat brains. While a zombie is all about the brains. So what does that look like? let's create a zombie class. So we're going to say class zombie, right? So this is the same. Now we're going to use a special word called extends, because we're going to be extending the previous class. So we're going to say extends, and we have to say the class that we're extending. So what is zombie extending? An extension of? Person. So I'll say person. Then we open our curly braces. And in here, we are going to make our constructor, just like before. Zombies, they take in the same qualities as a human, right? They're going to take in a name, an age, a sex. Is that all we had them take in before?
Leg time.
What?
Leg time.
Leg? That was for the animal, yeah. Not yet. And then let's say, what else can a zombie take in? Maybe a weight. We could give our zombies a weight. Does that seem reasonable? I know a human also has a weight, but... Or how about kills? Zombie has a kill count, yeah? And we'll say kills. And we can default that to 0, because hopefully they didn't kill someone before becoming a zombie. And then we have our curly braces. And so now there's a couple things that we're about to learn that are going to be a little weird. Okay, first things first. We want to do this, right? This dot name equals name. This is what we've learned to do so far today. And this is the inclination, yes? So we'll say this dot sex. Bless you. Very theatric. This dot kills equals kills, right? This is the instance. Anybody want to tell me what's kind of wrong about this? What's annoying? Yes, Sin?
Don't have semicolon.
Well, okay, that's not. I like the keen observation. The semicolons aren't going to break the code.
But you're repeated.
It's a stylistic. Thank you. That's what I'm looking for. Right? I repeated myself. I already had this in person. We're extending person, so why should we have to do all this crap that we already did in person? Well, we don't. Yeah. Right? So if we want to have these take after the same thing that this is inheriting from, we use the next cool word. It's super awesome. It's super. Okay? Say super, we invoke it, and then we pass in the same things that will be passed up the class to person. So I'm going to pass name, age, and sex. Should I pass kills?
No.
Why? Because kills are unique to the zombie, right? This just came in this class. But name, age, and sex was something we already had that existed in our person. Kelvin.
Can you skip like an attribute from the inheritor? You have to
No.
all the tree.
Yeah, I mean, well, I guess I could not have a super. I don't know. That's something you would want to play around with. Typically, if you are directly extending a class, you want everything from that last class, essentially. So let's make a zombie, shall we? We shall indeed. Is everything else commented down? Let's see if my animal ones are commented down. I don't really want these to drive me nuts. Okay. Okay, so instead of a person, let's create Mad Eye. And this will be a new zombie. We can call them Gloria, is that what you said? Moody. Moody. How old should this zombie be? It's not a vampire. All right, though, I like it. We'll do it anyway. 3,000. The sex, male or female? Neither? Okay,
No, please.
non-binary. I'm into it. Let's do it. Oh, MB. I like that. That's shorter. Okay. And then kills. They've already got one. That's fun. Okay. So we'll console.log Mad Eye. And let's run it and see what we get. So see, so now we've created this zombie class. And our mad-eye, when we console out mad-eye on line 39, we get back the class zombie and these properties that belong to our zombie. Yeah. What is what part? What is what talk?
The extending
Inheritance?
inheritance.
Excellent question. Yeah, right. When you write extends, you're saying you want to extend that class. We want to inherit the things from the parent class. Zombie here is the child. That's us, the children. Our parents are the people in this example. We are the zombies. Love band. Well, just the one. She's not there, I think it's called. Anyway, that's their best song. So this is zombies. So what's going to happen? Let's see what we think. If I write mad-eye and I say dot hungry, what's going to happen? So talk it over with the person beside you. See what we think is going to happen. We see my zombie classes right here. Okay, clap your hands once if you can kind of hear me. Clap your hands twice if you can kind of hear me. Okay, what do we think is going to happen? Who wants to share? Be loud and proud. Ashia.
It'll say the same thing that hungry returns I will be hungry.
Okay, I'm mad, or I'm Moody, right, because that's their name. Thank you. Okay, who agrees with that? Okay, any differing opinions? Yeah, Will.
I would say that if it inherits the previous class, what it's going to think is only what the constructor is specifying, not the other things. Just like the basic stuff from the what you created, like the arguments, like the name.
Yeah.
Stuff like that.
So what's gonna happen? Not sure. Okay, so we also have not sure. Who's not sure? Okay, so the piece. Everyone else is sure, so that's pretty cool. I like that. Okay, let's try it out, shall we? Let's get to the bottom of this. Let's Sherlock Nancy Drew this mystery. It says, "I'm Moody. I'm hungry." Aha! Right? Because it inherits from people, it will get all of the methods that people have. Pretty cool. Ashia, this was your prediction. Yeah.
So does it work the other way? So if
Mm.
we were to write another function for a zombie, will that function extend into person?
Interesting. I don't know. I do know, but let's let's test it out, right? So let's have a function called attack. Right, that seems to make sense. And we'll pass in a weapon. I know this is getting very violent. And we will return killing with a plus weapon. All right. So first things first. Let's try it for our zombie to make sure this works correctly. So we'll say attack. We can pass in a shoestring. Most powerful weapon out there. Very underrated. Do not underrate it. And it says killing with a shoestring. Or actually, kindness. Okay, so our zombie is killing with kindness, just like your parents probably told you to do. Okay, it never works, but zombies always lose in the movies. So, okay, so let's get down to Ashia's question. So we still have a Corey. If I change Mad Eye to Corey, killing with humor. We'll talk it over for 30 seconds with the person next to you. Will Corey get to kill with humor, or will something else happen? All right, clap your hands if you can hear my voice. Clap your hands if I have something in my mouth. Okay, thank you. What do we think is going to happen? Marvin? Nothing's going to happen. Bristol? Error? Ashia, you got to throw in your input because you were the one.
I said that it will work.
It's going to work. So we got it will work. Team it will work. Team error. Whoa. Team nothing will happen. Okay, so we're mostly on the error side, but we'll see what happens. Something will happen. Someone is going to run this code. Unfortunately, it is an error. I do not get to kill with humor ever. All right. So we cannot do that. Just like if I have a specific attribute, like let's say I lose an arm, my parents don't get to lose an arm, right?
They love you.
Calvin, you come from an extremely supportive, sick but supportive family. Yeah, Rafi. Oh, you're stretching. Oh yeah, me too. Farah.
Could they both extend, could two classes extend each other, like if they have both?
Interesting. I don't think that would quite work. One would have to be, well, we'd have to declare, how would we declare them both at the same time? Because one would have to be declared first. The one up here can't refer to the one down there. They don't get hoisted. In ES6, the classes don't get hoisted. You wouldn't really want to do that. That would be, if they're both doing that, they might as well be one class. Calvin.
If you add like a category to person, would you have to like continue to add that category into like the zombie?
What do you mean by category?
Like say like you added height to person.
So if I added like an attribute into the constructor, then yes, I would have to add that to the zombie. To the zombie, and then pass it into the super, yes. Only if I wanted it, I guess, but it might complain if it doesn't get anything, depending on how I've written my code. It might say like, hey, you didn't pass this in. If the person needs this item. I don't know, these are some edge cases. I'm not too worried about that at the moment. I don't want you to get too caught up on edge cases. You'll hit them as you, if we can get the baseline, just the base, the foundation, as we build and try to build our own things, then we'll hit edge cases and then we'll work around them. Okay, so we've got that Mad Eye can attack with humor. Lucky Mad Eye. So, but we also saw that Mad Eye was able to be hungry. What if I didn't? What's the other thing we have on here on human? We have sleep. So zombies never sleep, right? Unless you're watching Kingdom. Zombies don't sleep, right? Let's say they stay up all the time. So I accidentally wrote a function in my person class that I don't really want in zombie, or I want a different behavior. That's no problem for the following reasons. I can overwrite it like this. I can say sleep. I have to name it the same thing as before. Mine won't take an argument because it won't care. And it will return zombies never sleep. So, if we go here, and we go console, okay, console.log mad-eye dot sleep. Do we think this will work?
Yeah.
Yep. Good. Good instinct. Right? Zombies never sleep. So we can overwrite what a function does within the zombie class. Now remember, the person class, completely unchanged, right? Person objects still have their sleep and expect everything to stay the same. It's only the zombies that we've changed and updated, yes? Okay. So, one more thing. So zombies are hungry for what? Brains. So our human, or our person, has this nice little I, whatever, am hungry. Wouldn't it be fun if our zombie said, I, this name, am hungry for brains? So we can call super one more time. So what does that look like? So I'm going to alter the function. I'm going to call it, again, I'm going to call it hungry. So this will give us our new function. So right now I'm not really inheriting that much from person, but that's because it's just this little example. And I can say return. And now I still want that first half of the person thing, right? I still wanted to say I, Moody, am hungry. I can do that by this. I can write super, as in from the parent, and then I can call the function hungry, invoke it, and then I can just write whatever else I want for. So what does that mean we can do? We can go mad-eye dot hungry, and we'll get back I'm Moody, I'm hungry for brains. Questions on that? So from the child class, we can make a direct function call from our parent class by calling super dot the name of the function that we want, and then we can add things to it, or we can save that as a variable and add things. We can overwrite functions like we did here in sleep, and we can add new functions to our class. Okay, so whenever you write super, you're dealing with the parent class. Okay, so that was a lot. I recognize that. So we have an animal class, right? Now, the task, yeah? The task is to specify an animal, right? You could do dog, you could do something else, whatever. Make a new class for a subset of a specific animal, and give it a couple properties, pass things to the super, which is your animal class, and then make another function that calls to the super as well. Okay, so you're basically doing the same thing I've done, but with your own example, with starting with animal as your parent. All right? You're making your own class that will inherit from animal, that will extend animal, and you'll have a variety of methods that relate to the ones you wrote it for an animal.
When we create the name for the class, does all of them, not all the letters, but does the letters of each first word have to be capital, or the first letter has to be capital?
The name of it's proud camel case for any class name.
If we have more than two words.
Yes, so it'll be the regular camel case, but proud because it has the first capital.
Gotcha.
Yeah, of course. Just 1 second.
So we have this conversation. You don't think anything's online.
All right, clap your hands once if you can hear my voice. Clap your hands twice if you can hear my voice. Okay, how did this go? Yes? No? Maybe so? Okay, so that's really cool, right? This is a whole person object. Now they can do things. So that's pretty neat. Should we go any deeper? What do we think?
Yeah, let's go
All right, let's go down a little bit deeper. Okay, so we have an animal. I'm going to go ahead and extend our animal. Let's have a horse. So I'm going to say class horse extends animal. Oops. And then what do I need in the constructor? Name, color, leg count. Is that everything I had in there? And then we'll just throw an age in there. And so we'll call our super. So we're going to pass this up. So we're going to have our name, color, what was it? Thank you. Keep me sharp, please. And we'll say this dot age, and we'll assign this to age. And let's just run like let's write a little function that just says like running, and doesn't really do too much, just says return I run fast. Okay. So I'm going to comment out this other code because this other code is not totally what I want anymore. Okay, I want to like do a new concept slightly. So very quickly, I'm going to create a person. Okay, I'm going to recreate. Oh, I still wanted animal. Gosh darn it. Okay. Okay, so we've got the animal, we got our horse. Let's quickly recreate a person. So we'll just say class person, and this is going to be a constructor. This should be review. This takes in a name. And here we'll just say this dot name, and we'll add a name. And so far everything in our constructor has been something that we've directly passed in, right? But maybe I don't want that. What? Right? What? Oh, I'll put an age too, because I think age is a good thing to have for a person. People have pets sometimes, right? So I want to keep an array of a person's pets. Okay, so I could say this dot pets. And I'm going to just set that to an empty array. So now, every time we create a person, they start off with no pets. Right? There's no option to have them get pets. I could create that, of course. But for now, they just, boom, they have pets. All right? And inside my person, we're going to add a function that says add pet. It's going to take in a pet. And we're going to push this into our new pets, right? So we're going to say this dot pets dot push. We're going to pass in pet. And then we're going to return this dot pets so we can see the array. Questions on what this function's doing? Yeah, Doug.
Does that work like once a many or like once
What do you mean 1-to-1, 1-to-many?
Like, let's say like you have many pets. You
Oh well, I could do some silly stuff. I could set this up so that you can pass in multiple arguments. I don't want to do that right now though. But for now, we're just going to let you keep adding one pet at a time. And I'm also going to write a function called feed pets. Okay, and in this, we're going to feed the pets. So let's iterate through our pets. So we're going to say this dot pets, right? This is the array of all the pets. I will say dot for each. And so for each pet, I want to feed that pet. Right? So I'm going to say pet dot feed. I'm going to pretend that my pet has something for feeding. Okay? I'm going to invoke that. And that's all that's going to happen for this. So we're just going to iterate through the pets. For every pet, I'm going to feed it. Okay? So far, okay. So now let's add something to our animal class real quick. So we'll go back to our animal. And we'll just do it for our horse for now. And I'm going to write a function called feed. Okay, hang on, something weird happened with that. Okay, so I'm going to write a function called feed, and I'm going to just console log for now. I could like update something, yeah, but for now I'm just going to console log that, and it's going to say this dot name plus is eating. Okay? Question? Weird? Too weird? Not yet, right? Okay. So, on our horse class, we have a function called feed. I can invoke feed, and it says the horse's name is eating. Yeah? And I also have a person class that feeds pets. Okay, so how can I make these similar? So I'm going to, instead of having this horse here, I'm going to make a new horse called orange pop white for, what else? Does my horse expect anything? I forget. Leg count and age, or legs. Is this I think that's everything, right? And I have seahorse. I'll make this a horse too. Doesn't matter. So now I have two horses, right? Okay. This is kind of fun. Okay, I'm pretty excited. Okay, so we're going to say, I'm going to be the person, because I'm the star of the show here. I'm going to say let person, and it's going to be Corey, and they're 100. So far, no big deal, yeah? And we're going to console.log Corey. So we're going to see the instance of this class, yes? Okay, so we run it. Oh, what are we in right now?
You just have to click terminal.
Thank you. And we see, okay, so there's this Corey, and Corey has no pets. Okay, well, let's give Corey a pet, shall we? So I am going to go ahead and say Corey dot add pet, and I'm going to pass in an actual animal object, right? Or specifically the horse that we created. So I'm going to pass in horse. Right? So now I have two console logs, and we see the age is undefined because I don't really care about everything like that, right? But we're seeing that Corey went from no pets to now Corey has a name, an age, and a pet with a horse in there. So Corey has his first horse, right? Okay, that's kind of fun. Let's give Corey another horse. So I'm going to just do this. I'm going to add seahorse here. And I'm just going to move this down. Whoops. Don't know where that came from. Don't know, don't care. Okay, so now we have our Corey object. We're going to add two different horses. We're going to add strawberry cream and orange pop, although we're calling them horse and seahorse, and console log query at the end. So let's run it. We see that now our query object still has the name of query, the age of 100, the pets, and we can have horse. This horse has orange pop, this horse has strawberry cream. Pretty cool. So now query has horses. Okay, but what happens if query wants to feed the horses? Let's do it, shall we? So I'm going to say query dot feed pets. I invoke, I save, and we now get orange pop is eating, strawberry cream is eating. Yeah, it's cool. So what's going on here? Can somebody explain what's going on? Somebody want to take a shot at it? Yeah, Calvin.
I think that the object query is using like a callback function to go into pet, and that's like running the function of the.
Yeah, sort of. So what's happening here is we've got Corey is a person. Thank you. And Corey can add pets. And those pets that we're adding are these real pet objects. They're these real, like whole pet, like a whole pet, everything a pet can do. And then Corey can interact with his pets in a certain way, right? I could pet my pets and have my pets do things. I could kill the pet, I could do anything, right? Take it to the vet. And so we have this.pets, this gives me back my array, and then I'm just iterating through these pets, and I'm calling a method on the pet. That pet has the method right here. In my horse, it has a feed method. So you have to know what methods everything has. And we say, okay, this.name is eating. And so when we do this, and we do it in a loop, we iterate through the pets, and we say, okay, that orange pop is eating, and then strawberry cream is eating. Questions on how that's working? Do we understand? Do we see why this is really cool? So this is really cool because we can start to build games and things, because everything can be considered an object. This is like one of the core concepts of a lot. Some programming languages are like all object oriented. JavaScript is nice because it can be functional programming or object oriented programming. Those are the two main paradigms. But everything can be an object, and they can all interact with each other in certain ways. So if we were playing tic-tac-toe, we could have a board class that keeps track of just the board. We could have a game class that keeps track of the logic of the game. We could have a human class that keeps track of the moves it makes. Right? So there's a lot, and I know it's a lot right now. Right? It's the end of the day, 8-hour day, big day. But we are going to keep working on these. We're going to probably work on these for like the next day or two, couple of days, and then you're going to get a new project, your second project, final project of Unit 1. Yeah, probably Hangman, yeah, where you will be creating your own terminal game again, but this time using object-oriented programming. It's going to be pretty sick. All right, so that's like all that I have for lecture. If people have questions, I can answer. Yeah, Rob?
We have to do the exit for what we did earlier today.
Yeah, if there's an exit ticket, definitely. The constructor, so we didn't go over constructor functions like we did and we didn't. We did it for ES6. So if you see the constructor function thing, I think that's the exit ticket today. Don't worry about that. There's two? Yeah, don't do the constructor one. We're skipping that for right now. Any other questions? Yeah, Dwakabasi.
So let's say you wanted to do like orange pop with egg and then clean whatever it's eating, whatever it's eating. Would you make that 2% of your function?
Well, I could pass some different things in and feed them different things. Totally. Okay, so if I were you, for the remainder of the time, I would like just try to build my own kind of version of this a little bit, but if not, we're going to keep going over tomorrow. Keep looking at those array methods, those high-order functions. right? That's the for each, the map, the filter, the every, the sum. And good job today, yeah. That's it. Yeah, thanks, Jay. Yeah, oh yeah, thank